Students, I am discussing your doubt questions. In this diagram is asking in which resistor the maximum heat is dissipated. The maximum heat is dissipated in which resistor it is. Okay, fine. Now, here first try to understand power equal to heat energy divided by time. Therefore, heat energy equal to power multiplied by time. This is the equation. Next question arises in your mind. There are three formulas are there for the power. Power equal to V into I. Power equal to I square into R. Power equal to V square by R. Now, which formula you have to use? This is the question. When resistors are connected in parallel, use this formula because voltage is same in all across each resistor. You have to use for this formula for the parallel connection. That is what? Parallel connection. This formula you have to use it for the what? Series connection. When resistors are connected in what? Series, because the current is same. Okay, now power equal to V square by R. Therefore, H equal to what? V square by R multiplied by what? Time. This is the formula. Okay, fine. Now, in this diagram, just I will simplify it. These three resistors are connected in parallel. That is connected in parallel. Okay. Again, these two are also connected in parallel. These two are connected in parallel. Okay. And this is connected to the battery. Voltage is what? This is 3 ohm. This is 6 ohm. And this is what? 2. Similarly, this is 5 ohm. And this is what? 4 ohm. I will not do detail. The effective resistance of this will be what? Rp1 equal to what it is? 1 ohm it is. Because it is 1 by 3 plus 1 by 6 or so. Okay, I will do it. 1 by Rp1 equal to 1 by 3 plus 1 by 6 plus 1 by 2. What are the LCM? 6 is the LCM. 2 plus 1 plus 3 equal to 6 by 6 equal to 1. It is 1 by Rp1 it is. Okay. Therefore, Rp reciprocal you take it equal to how much it is? 1 ohm it is. Next, what about this part here? This part is again Rp2 equal to Rp2 equal to, you know the formula, R1 into R2 divided by R1 plus R2, 5 into 4 divided by 5 plus 4 equal to 20 by what? 9 ohm here. So that this value is 20 by 9 ohm here. I hope that is clear for you. Now, I will redraw the diagram. This is 20 by 9 ohm. And this is how much? 1 ohm here. And this is connected to the battery. Voltage is 4 V. And here the current is what? Sending. The same current is passing here. Here also the same current I is passing. But here the voltage is different. V1. Here the voltage is what? V2. Now I will draw the equivalent series combination. I will draw it. The equivalent series. What is that equivalent value is here? This is the equivalent resistor. What is equivalent resistor? RS. What is RS? RS equal to R1 plus of what? R2 it is. This is equal to 1 plus 20 by 9 equal to 29 by what? 9 ohm. It is equal to 29 by what? 9 ohm here. Okay, fine. Here also this current is I. In the equivalent resistor also the current is what? I only. The current is what? I only. You know it. And we know the formula. I equal to, for this resistance, V1 by R. This is R1. This is R2 I will call this, equal to V2 by what? R2 equal to V divided by what? Rs. Because this voltage is what? V, and this is what? Rs. Then what is the value of V1? V1 equal to V divided by Rs into what? R. Correct. That. This is equal to, okay. What is V here? I don't know that is V. I don't know that is V. Rs is how much? 29 divided by what? 9. Okay. Into R1 is what? 1. Can I write 9 by 29 into what? V. I can write it. This is V1. Then V2 equal to V divided by Rs into what? R2 here. Okay. V divided. Rs is how much? 29 by what? 9 into R2 is how much? 20 by what? 9. This I will simplify it. V into what? 9 divided by 29 into what? 20 divided by what? 9. Here this 9 get cancels here. It becomes 20 divided by 29 into what? V. That is the yes matrix. Okay. V1 is known, V2 is known. Here V1 is known, V2. Here also we can draw the conclusion here, that is. Here V1 is 9 by 29. V1 is much less than what? V2 here, that is. V2 is more, then power generation is also what? More. Here also we can draw the conclusion, that is. Okay. Next, say here what? Here. Now power for the previous this one, this here, okay. V1 is known, and here. Okay. Here the voltage is how much it is? V1 here. Here the voltage is how much it is? V2 here. What is V1? V1 equal to how much you told that? V1 equal to 9 by 29. It is what? 9 by 29. 9 by 29 of what? V. V2 equal to how much it is? V2 equal to 20 by 29. 20 by 29. 20 divided by what? 29 into what? V. Now I can use this formula. This I will calculate. For this resistor, H1 equal to V1 square divided by R into what? T here. Now the question is, which resistance you have to use it? But you see, H and R, how they are related? Inversely related here. So that if R is low, then heat generation is what? Maximum. So that I will use this one, equal to H1. V1 square is how much? 9 by 29 whole square into what? Into V square into, because it is V is there, into 1 divided by, it is what? 2 multiply by what? T. Yes. That. Similarly for this part, this is the lowest one. If R is low, H is more. So that H2 equal to, can I write like this? V2 square divided by R into what? T here. Okay. What is V2? It is 20 divided by 29 whole square into what? V square into 1 divided by 4 I am writing into what? T here. Students, you compare yourself here. Here, you don't bother about V and all that. This quantity is very low. It is. This quantity is more compared. So that H2 is greater than H1. Where is H2? H2 is the heat generated in the what? 4 ohm resistor. So that the answer is 4 ohm it is. I hope that is clear for you. This is the right answer. Next. 2 short bar magnets of a magnetic moment M each are arranged at the opposite corners of a square of side D such that the centers coincides with the corners and the axes are parallel. Okay, fine. Now, if like poles are in the same direction, he said that like poles are in the what? The same direction, he told that. Okay. Before that, you try to understand, this problem is based on the axial line and equatorial line. For the axial line, I am saying that is, suppose this is North Pole. Okay, 1 minute. Yes. I will take, this is what? North Pole. Okay. This is what? 1 minute, 1 minute. Okay. Better I will take it like this. This is North Pole and this is what? South Pole. I want to calculate the magnetic field at this point. Okay. This distance is what it is? D here. Okay, D. Students, here it is North Pole. Now, the magnetic field at this point due to North Pole is like this. It is Bn, I will call this. Next, magnetic field due to South Pole. This is South Pole. No, this is South. Here, for this, it is like this. Bs. You see? I drawn this length is less and drawn this length is what it is, more I drawn. That means the magnetic field due to North Pole is greater than the magnetic field due to South Pole. So that for the axial line, the resultant field is acting like this. Br equal to Bn minus of what? Bs. It is acting along this direction. It is acting. This first part. And what is that equation here? Magnetic field for the axial line equal to mu naught upon 4 pi into what? 2m divided by what? D cubed. What is D cubed? D is the distance between center of the magnet to the point where you want to measure the magnetic field. This is for the axial line. Okay. Next, for the equatorial line, I am writing this equatorial. Okay, this is what? So, this is what now? This is equatorial. It will bisect. And this distance is from this point, it is what? D. Here I want to calculate the magnetic field at this point. Now I will join it. This is North Pole now. So the direction of the magnetic field is like this. V. For this South Pole, I will join it like this. The direction is what? Like this. It is Bs. Now this is the what? The resultant field. This resultant field Br is equal to, it is nothing but equatorial line. It is nothing but equatorial line. For this, formula is mu naught upon 4 pi m divided by what? D cube. Try to understand what is axial line and what is equatorial line. Now, I will draw the diagram. This is the square. Okay, perfect. Square is there. Square. Okay. Here magnets are placed. One magnet is placed. Right. Here another magnet is placed. Another magnet is placed. Opposite corner, and this distance is also what? D. From where? From the center to the what point? I want to measure the magnetic field at this point. Students, now I will say that this is North Pole and this is what? South Pole. This I will call it as a magnet 1. I will call it as a what? Magnet 1. It is for the magnet. For the magnet 1, with respect to this point, it is an axial line and the direction is like this. It is B1. It is an axial line. So that B1 equal to B axial equal to, we know the formula, mu naught upon 4 pi into what? 2m divided by what? D cube. Okay, fine. Next, let us talk about this magnet. This is the magnet 2, it is magnet. From this center to this point, again this is the what? Distance D. It will be, with respect to this point, this magnet, it has to be equatorial line. It is an equatorial line. Now you say, this I will call it as a North Pole and this I will call it as a what? South Pole. For the North Pole, you say, just I will draw another diagram. Then this is north. This is north pole, this is south. I want to measure the magnetic field at this point. You see, draw the direction. It is like this. For this, it is like this. This is BS, this is what? BS. The resultant of these two, it is like this. It is B2. Now, the resultant of these two is acting like this. B2. B2 is the magnetic field produced by this magnet. It is with respect to which line here? Equatorial line. It is for the equatorial line. So that B2 equal to B of equatorial equal to mu naught upon 4 pi into m divided by what? D. Since these two are acting in what direction? Opposite direction, that is what. So that the resultant magnetic field equal to V1 minus of what? V1. Of course, V1 1. Here 2 is there. Here only no 2 here. Resultant magnetic field equal to mu naught upon 4 pi into m divided by dq into bracket 2 minus of 1. This is equal to mu naught upon 4 pi into what? M divided by what? D. This is the right answer. Yes, tell me. Is there M by dq? Yes, this is the right answer. Next. A slab of material of dielectric constant K has the same area as the plates of parallel plate capacitor. I solved this kind of problems, 2-3 problems I solved in the regular class. He is asking ratio of C by C naught. C means presence of dielectric. C naught means in the absence of dielectric. Okay, fine. I will draw the diagram. This is your capacitor. This is D. What is filled here? Air is filled here. For air is filled, C naught equal to formula epsilon naught into A by D. This is equation number 1. Now this capacitor is filled with some dielectric material. What is the thickness? 3/4, 75% is filled here. Okay. It is filled. This is filled with the dielectric constant. And this thickness equal to 3/4 of what? D. Rest of the thing is filled with what? Air it is. That's all. Here also air. This also what? Air. And one formula is there. C equal to epsilon naught into A divided by D minus of T into bracket 1 minus 1 by K. This is the standard formula. Now I will substitute C equal to epsilon naught into A divided by D minus of 3/4 of what? D into bracket 1 minus 1 by K. Now I will simplify this term. C equal to epsilon naught into A divided by D minus of 3/4 D plus of 3/4 into D by what? K. Here this quantity, it is 1 minus 3/4, 1/4. So that C equal to epsilon naught into A divided by D by 4 plus 3D by 4 into what? K. Here you see D by 4 is a common. This is the D by 4. This D by 4 is common. This is equal to what? Epsilon naught into A divided by what? D by 4. Within the bracket 1 plus 3 divided by K. Again simplified. This C equal to epsilon naught into A into what? 4 divided by D into bracket K plus 3 divided by what? K is there. Can I write like this? This is quantity is nothing but what from equation 1? C naught. C equal to C naught. I will send it numerator K into what? 4 divided by what? K plus 3 it is. Anyhow, he is asking the ratio, he is asking here this term. So that C divided by C naught equal to 4k divided by what? K plus of what? 3. So then, which is the answer? This is. Okay, I hope that it is clear for you, that is. But especially question number 26 is very lengthy question, that is. Okay, so now I will stop my discussion at this point.